Hi, I'm Luca from taskwave, and today I'm going to show you how to actually submit one of these terminal bench style tasks. So, okay, you've already completed the onboarding. You passed the final assessment, so congratulations. Congratulations on that one. And that means you'll have at your disposal the taskwave contributor repo and also a special personal contributions repo. And so, okay, that's all we have at the moment. And we're going to go from this stage to having actually gotten a complete task that we're ready to submit. So first things first, let's pull down the contributor repo and see what it's like. This repo here contains tools that you can use to make it easier for you to make a task. Probably the most important tool in here is a template task that you can start with. So that'll make things much, much easier. So that's the first thing we're going to do is we're going to go ahead and pull down this goddamn repo just somewhere locally. So I'll just open up a terminal. And yeah, I put everything in code. So yeah, we're just going to clone it in there. Completed. Yep, it's completed. Nice. And let's hit the README up, see what's in here. So this tells you how to use this repository. And the first thing it asks you to do, because this repository has this special property where we're going to keep overwriting this repository and pushing it. So what we're going to be doing is squashing all the commits into a single commit of this repo and pushing it so that you can pull it and stay up to date. So that means that you don't want to make any changes to any of the files in this repository, because when you pull, it'll just be overwritten. The place where you make all your changes and do all your local coding and create all your tasks will be in your personal repository. And the thing that you should do, and it says all this in the README, is clone your personal one into this one. So you'll have like your local repository will be sitting inside this contributor repository. So, okay, open it up and we'll just go to our own personal one here. And we'll just clone it literally inside this directory. So ls, you can see all the contributor code is there. So yeah, git clone, boom. Okay, so great. Now we have two Git repos. We have the main repo, and then we have a nested smaller repo, which is our personal one. All our changes should go in the personal one. So let's start by making our first task. So what we're going to do is we're going to check out a new branch. And we're going to call it first task for now, just because we're not. We'll call it first task 2. It already exists for me because I've been playing around already. But okay, now we're in a new branch called first task 2. The first thing we're going to go to this our tasks folder. This contains tasks that the taskwave team have actually made already. We've made a few more, but these are ones that we're just going to show you as examples. And we'll copy the template task. This is going to be used to build up other tasks into contributor tasks. Okay, great, template task. And then if you go to git status, we see that there's been a change. You can see these are all the new files that have been added. Here we go. And then we can just git commit. Okay, so that's all good. We've got a template task on the way. And eventually, when it comes time to submit our task, and we're pretty happy with our task, we are going to do a pull request, and we're going to merge it into a special branch that's been created for us called review. So when we're ready to submit a task, we'll merge that task into review. Now I need to push this up to this first task, and we'll be able to see it up here. With a bit of luck here, now we'll be able to see first task 2. Great. Okay, here it is. So when we're happy with our task, we'll merge first task 2 into review, and then that'll be our submission. At that time, some automated checks will run, and you'll see a GitHub bot come and run some automated checks. And that will be, yeah, that'll probably be a bit disappointing the first time you see them, because you'll see you thought your task was really good, and the automated checks will say, no, this all failed. So to make sure you have a good experience when the automated checks run, you should just run the checks yourself, and I'll show you how to do that as well. But okay, at the moment we only have a template task though, and we need to make it good, because at the moment it's pretty average. So let's just have a look at the template task, and then we'll talk about coming up with ideas for tasks. I've made a lot of tasks, by the way. I find it really fun to write tasks, but it is a lot of effort. It's really interesting. The challenge of trying to work out how to trick a model it's really interesting because you always think it's going to be easy. You're like, oh, I think this will trick the model. And then it turns out that your instructions are just vague. That's usually what it is. And actually coming up with a problem that models fail at that is not ambiguous it's pretty tough. And it's a very interesting challenge. And it's sort of a challenge at the very edge of, our sort of progress as a society in terms of intelligence. So I think it's very, very interesting. But okay, let's have a look at the template task. So the most important file is called task.yaml. And this describes what the task is. In this case, the task will be completed if the agent can create a file called app.test.txt and include in it this sentence. So that's actually pretty easy. Great. It's an easy task. The next most important file is solution.sh. And this is the gold shining perfect example of a solution of how to solve that task. And so here we go. If you run this solution.sh, that task will be solved. Now, what actually happens is everything gets run inside a Docker file. So I'll actually bring up the terminal bench documentation. So here we go. This is my graphic that I'm very proud of. So this is how terminal bench works. You have a task.yaml and the agent has to complete it. And the solution is the example. It's like a perfect agent that will definitely complete it. And the tests, which we can see over here, they're in, here we go, test output. They will run, and the idea is they will only pass if the agent has been successful. So in the easy case, you have the task, and then you run inside this Docker file, you run the solution.sh. And then the solution.sh changes the environment, and then we run the tests, and then the tests pass, which let's have a look. Like, what are the actual tests here? It checks that the file exists. Great. Yep. And then it also checks that it actually contains the exact text that we needed. So perfect. Great. Awesome. So, okay. Those are the tests. They'll only succeed if the solution was correctly applied. And just sort of like a little bit of something about the infrastructure of terminal bench. We actually run the tests through this run tests file. And you can also maybe install some test dependencies if you need to in this file, or like move some files around to make the testing easier. I don't know. But usually the tests will just be in this test outputs, and you can kind of ignore this run tests file. So, okay, everything runs inside a Docker container, and then you have this Docker file and the Docker compose, and they define the Docker container. So for instance, maybe your test includes some machine learning data. Well, you'll need to include that in the Docker file in order for that test to be, fair. So, okay. Then you have the Docker compose. I would ignore the Docker compose for now. In fact, we sort of encourage everyone not to use Docker compose ever. In theory, you can use it for spinning up multiple services and then have the services talk to each other. Like maybe you want to simulate that agent has to talk to a different server. And as cool as those scenarios are, and as fun as it is to make tests like that, they make it very hard to run multiple Docker images at once. They kind of allow, they mean that the context is now leaked out of a single Docker container. It's now using up ports on the host machine and all that stuff. So it makes the tests sort of not very replicable, which often makes them inappropriate. So we ask that you don't alter the Docker compose at all. Leave it exactly as it is from the template task and just make alterations to the Docker file. And if you want to spin up multiple servers and stuff, spin them up inside the one Docker file. That's perfectly fine. We also ask that you don't include any internet use. So if the perfect solution, it has to be achievable inside the Docker container without any requests being made to the internet at all. Okay, so that's the infrastructure, but how do you actually make a good terminal bench task? So the best way to answer that is look at other people's tasks. So at the moment, there are these two tasks that we have given you that we think are pretty good. One is bank trans filter, where we provide them some data that has some typos in it. And the solution is to write a Python file to filter through those bank transactions and then filter them correctly, even with the typos, using some like fuzzy matching. And that's the solution. And then SSH auth is another one that's kind of more interesting. This one involves a Docker Compose file, although if you're doing this yourself, you'll have to make sure that you don't alter the Docker Compose file. It's just the default one, and that all the services are like spun up locally. And the task in this case is you spin up one server and then give it SSH access to another server, and then disable password access for both of them, and then confirm that SSH access works. So this kind of task is really good, actually. Tasks like this are exactly what we need, because these are things that models often struggle with. The Python example, it's interesting because it's a bit complicated and requires a bit of human context, and okay, that's cool. But the solution is just one big Python file, right? And that's what we want to stick away from. In fact, we want solutions that require at least 10 commands to fully solve. And that means that the agent will run at least 10 commands. You don't have to run 10 commands for the perfect solution, but to solve it, the agent will have to run at least 10 commands in order to actually solve the problem. So because of that, sort of multi-step processes like SSHing into servers and spinning them up and spinning them down, those are the kind of tests that we really like and are really good. This is in my opinion, this is a really good example of a test, this SSH auth one. And you can think of similar things maybe to do with Postgres, where like maybe there's a Postgres server that's been misconfigured, or maybe there's like a DuckDB server and there's a Postgres server, and you need to like communicate between them or something, or perform a data migration, something like that. We also love machine learning tasks. So at some point, we're actually going to stop accepting non-machine learning tasks, but we'll always be accepting machine learning tasks. We really want more of them. Machine learning stuff, so like training models, debugging models, serving, deploying models, converting models into different formats, and things like exploratory data analysis, statistics, things like that. So the whole broad breadth of machine learning, really love tasks like that. But okay, so here are two examples of tasks. You can go ahead and look at them. And there are way more. So if you actually look at tasks rather than our tasks, these are all the tasks that have already been submitted to Terminal Bench. So I would, if this is your first time you're contributing, just read like 2 or 3 and get an idea of the kind of tasks that people submit. Okay, so for example, let's start off by taking someone else's task. This is a great task here, analyze access logs. And we're just going to copy that, and we're just going to use that instead of our own task. We're just going to copy this task in. And obviously don't do this. You're not allowed to do this. And we have a plagiarism checker, which will catch you if you try to do this. But just for now, as a learning exercise, let's just start with this task here, this analyze access logs task. And because it's a fairly reasonable, good task. So, okay, this is the instruction. Analyze the web server at access log, okay, and create a summary report containing total number of requests, number of IP addresses, top URLs, and the number of 404 errors. Okay, so it looks like there's a log. This test is sort of centered around this log, apparently. So here's the log, okay. And this is a log. It's pretty big, as you can see. And this will be accessible to the model. And the idea is the agent has to look at this log and then complete this. So basically, count the number of unique IP addresses, the top URLs that are in there, and then number of 404 errors. Just like some basic statistics to pull out of the data. And tests like this are pretty reasonable, right? I'm sure you can think of a test that's kind of similar, a task that's kind of similar that you could make yourself. So, okay, this is the access log. Is there any other information? No. Other than that, it's a pretty basic test, really. So what's the solution here? Okay, great. So firstly, you count the total requests. Okay, you can just do that with a nice terminal command. That's great. And then the unique IPs, you do an awk command. And then again, you can just do awk, and the errors you can also do awk. So great. Fantastic. And then you create a report with the totals. So, okay, great. This is a very nice, this is probably not like a very hard task. If your task is any easier than this, it probably won't get accepted. So this is about as easy as we can get. But okay, this is actually a pretty nice, pretty decent solution. We're just copying this across for now. So like, imagine that we've gone ahead and we've like, we've done our thinking, we've actually thought it up and thought up a great, unique problem. And while I'm on this topic, one of the things that's really important for any solution that we accept is that both the solution and the task are not generated by AI. That's very important, because if they are generated by AI, they become a lot less valuable for training large language models to be better. So that's one of the main checks that we do, is to confirm that both the task and the solution are original. Now, if you need help generating other files, like maybe you want to generate some tests using the AI, or maybe you want to generate some data or something, that's okay. That's fine. As long as the tests look reasonable, because, we'll have a reviewer look over the tests, and if the tests look a bit silly, then we'll knock you back. But you can use AI for anything except the task and the solution. That's the basic rule. So, okay, this is some nice human-generated task. Great. And then what was their solution? Here we go. This is their nice solution over here. Copy that in. And then we have to copy the tests as well. And again, we'd be editing this ourselves. And in this case, we'll just copy the test. Does this look reasonable? Okay, so what does this do? Yeah, okay, so it's sort of like grepping. It's like searching through the output text file and making sure that the numbers all match up. So that's great. And then it's just checking the top URLs match. Okay, and this is a great test battery. This kind of length is fantastic. Not too long. It tests very specific things. So honestly, this here is a really, really good example, and I would recommend you try to follow this example. Now, the last thing we'll have to copy across, of course, is the access log, because the access log is needed for the test, obviously. Okay, so access log, and then we'll also need to change the Docker file. So as you can see here, yeah, they've changed the Docker file in that they add the access log in there. So we'll have to also change the Docker file here. Okay, so now, first thing to do is, we think we've got a good test. Our test, conceptually, it's all sort of hanging together. Now the question is it actually set up correctly? So what we want to do is a NOP run, which is like a no-op run, which just confirms that the tests fail in the correct manner. Like the Docker file spins everything up and everything looks fine. The tests actually run, the tests fail, but they do actually run. There's no errors, nothing like that. So if we go to the README here, it tells us how to do all these things. And when you make a submission, all of these checks will be run in an automated fashion against your PR. So, like if you submit it, we'll catch you out if any of these don't work anyway. So you may as well do it yourself and sort of save yourself some time. Okay, so first test we're going to do is the NOP test. I like to just keep a file called commands.sh. And we have to put it in our own personal repo because everything in the higher one gets overwritten. And this is I'm just going to keep these commands here that are useful to me. So task ID, we're going to give it a new name. At the moment it's template. We'll just call it access log. Great. So task ID is access log. And then my GitHub name, of course, so which is Lewington Pitsauce. So just copy it across. Yeah. Okay, so what this will do is it will run, well, this is the Oracle command. We want the NOP command, which just makes sure that everything fails properly. NOP. Excellent. Okay, great. Run the NOP. And as you can see, what's it doing? It's like downloading a bunch of things, it looks like. It's preparing some packages. Yeah, so what's actually happening here? We're actually running the Oracle. We shouldn't be running the Oracle. I'm going to Control-C that, stop it. We want the NOP. Run the NOP. And so conceptually what's happening now is rather than the solution.sh, we're just running a no-op, but we are spinning up the Docker container and all of that jazz, and then eventually running the tests. So we should be able to see some logs which kind of, okay, so it doesn't actually like that. It doesn't like that at all. And the reason is because I'm inside contributions Luca Lewington Pitsauce, and I've started it. I've added that directory in there as well. So I don't need to do that. And so we'll just try with this now. Okay, and then it says running tasks. And what we'll see, just as soon as that starts, what we'll see is there'll be a run generated somewhere. Here we go, runs. Now, you shouldn't commit these because they're very verbose. So what I'm going to do is I'm going to put runs in here in the git ignore. And runs will be created in whatever directory you're in when you run this command. So if I was in another directory, the runs would be somewhere else. But okay, run finished. It says unresolved trials. It failed. That's exactly what we expect. Great. So while we're waiting, I'm just going to run the oracle and see how that works. Now, the oracle is the perfect solution. So the oracle is the solution.sh version. So, okay, I'm just going to run the oracle. And while I'm running the oracle, I'm going to have a look at the results that we just got. Okay, so these are the results. Parser results, the 3 tests failed. When you see something like parser results and failure mode unset, that's a good sign. It means the actual, the test actually ran. That's good. But sometimes you'll see something else, which is like a bit more scary. And sometimes there'll be like Docker errors and things like that. So look out for that. But this is looking good so far. And then you can see the access log, and this shows all the logs that were created and captured inside the Docker container. So this is the agent log, and this is like an empty agent log because of course it's the NOP, so the NOP does nothing. So okay, that's why we see like nothing over here. And then we have the test log, and this shows you what came up during the tests. And as we can see, these are the failures, and now we can look at exactly what the failures were if we want to, know a bit more about that. Okay, this is all expected because the NOP agent is supposed to fail. So in theory, the oracle should now pass. And this is, again, one of the automated tests we're going to run. Your oracles have to pass. If they fail, the task can't be submitted. Okay, so, right, nice. Trial resolved. Excellent. And we can look at the results. And here we go. Passed. Failure mode unset. So that's all really good. This means that we're sort of looking pretty good. I'm just going to add an error into the Docker file to show you what it'll look like if we do that. So I'm going to go like this, access law. So obviously there is no access law file. So if we run the oracle again, in fact, even if we run the NOP again, it'll show us a different error. And it's just good to know what that looks like. Okay, great. So firstly, we see there's this Docker printout here. And so when you see a big Docker printout, it's like, okay, there's something wrong. Then when you look at the results, it says failure mode, unknown agent error. So that means when we try to run the agent, we hit an unknown error. When you see this, that's really bad news. That means that you have to try again, right? You have to do something else. Okay. So, right. So that we'll fix that again and then run the oracle again just to confirm that everything's working. And when that's done, we should probably make a git commit, I reckon, because we're sort of in a good spot here. In fact, I'll just make a git commit now. Okay, so, so now here's the thing. I'm now upper directory. I'm back in the password contributor, but when I'm doing git operations, I should be inside contributions because I want all the git to be isolated in that subdirectory. So git status, it's all looking good. Yep, so we've just added a new task. This all looks good. We added the command.sh, that's all fine. Okay. Nice. We'll just add a small commit. I personally don't care about git commits. So, but maybe you like writing nice git commits. I don't care about git commits. Okay. So here we go. And again, resolve trials 1. So everything's looking good. So we've got this task. It's passing. It's kind of well formatted, but is it worth submitting? Is it something that's actually going to trick an AI model? And this is where we get to the fun, interesting bit. So we'll go back to the README. And you can see that's only the first check. So these are the basic checks, is the task correct? The next thing we're going to try to work out is how hard is the task? So we work that out by running 2 different agent checks. We use GPT-5 and we use GPT-OSS. And the idea is that GPT-OSS must fail at least once out of 5 times, and GPT-5 must succeed at least once out of 3 times. The reason that is that once GPT-5 succeeds once, then we know the test is fair. If GPT-5 always fails, then maybe the test isn't fair and maybe there's something wrong with the test. Maybe there's some issue with the test. If GPT-OSS succeeds every time, then the test is way too easy, and it's not going to be challenging to the best models out there. So, okay, let's go ahead and put this in commands. Now, what I would recommend is actually creating like a single file which has all these commands and runs them all at once so that you don't have to like run them all sequentially. And in fact, I'm going to start building that now. I'm going to add both of these to another file. I'll call it, I don't know, call it, yeah, hardness check. Okay, so now I'm just going to run hardness check right now, and hopefully that'll be fine. Permission denied. Oh yeah, of course. And it's going to run 2 more runs in sequence. The only difference between what we just did and this is that an actual agent is going to be spun up inside the Docker container, and the agent is going to attempt the test multiple times. Okay, but before we can see, I'm getting errors. And here's the thing. We're going to need a API key for OpenRouter. Because at the moment it's giving me this, like no auth credentials. So we're going to need an OpenRouter API key. GPT-OSS is very cheap. GPT-5 is less cheap, but we're only doing 3 attempts. Each time you run this check, it'll cost maybe about $1 US. So if you're really concerned about that, reach out to us on the in the Discord, and we'll see if we can get you a key. Like I'm pretty sure we can get you a key. But okay, so I'm gonna set the OpenRouter API key. I'm just gonna do that with an environment variable. So okay, so I've set it. We're going to try this again. Hardness check. And hopefully we won't get hit by all those errors. It's probably a good time to talk more about this TB command. So this is a command line interface that we've forked from the official terminal bench command line interface called TB. So if you will look at their documentation, you'll see, a lot of the information that you need. But basically, it's a pretty damn good tool, and you can run help to get more information. And what we want to know right now is, I think there's an argument called concurrency or something. So we'll go tb run help. Oh, by the way, I'm using UV in this case. I'm using UV, which is like, it's kind of like poetry. It's like a Python runner kind of situation. Right, run. And I just want to see, there's a concurrency, and what the concurrency thing will do is it'll allow multiple tests to occur at once, which makes this process much, much quicker, obviously. The only thing is, each instance spins up a different Docker container. So firstly, you have to make sure there's no like contamination of the environment between containers, right? They're not all using the same port or something, because that'll cause failures when you don't have any failures. And also you have to make sure you have enough memory and RAM and stuff and like disk space to actually handle 2, 3, 4, 5 Docker containers. I have a MacBook with 16 gigabytes of RAM. So I find my N concurrent, this is what we want, N concurrent, can only be 2. 2 is all I can handle before I start getting strange like memory issues and things like that. Okay, so that would make it like a lot faster. Okay, so at the moment we're starting this run, and as you can see, OSS, that was really quick. So GPT-OSS already ran 5 out of 5, and we can see the results here, and it passed 40%. So that's great. That's the kind of hardness you want. It's passing sometimes and it's failing sometimes. If it fails all the times, that's fine. The sort of ideal hardness is it fails 4 times out of 5. So like 20% pass rate, but 40% is still okay. What's not okay is if it passes every time. That will reject that. But okay, so these are the results. It's run it 5 times. First pass, pass, passed, and then we're going to pass, pass, fail, pass, 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 fail, 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 and then fail, fail, fail. Now, we can actually even see exactly what happened, like what the model actually did during its commands. So if you see, sometimes it'll be here. Here we go, agent log. So this is what the agent did. This was analysis, blah, 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 and then it ran these commands. It cat cat report, ls app, and then it did sort of another iteration, another bunch of commands, more keystrokes, total requests. So in this case, it looks like it ran some commands, but let's see, was this a passing one or is it a failing one? Let's see. This one, it was a failing one. So it failed, and we can even see why it failed. We can look into why it failed down here, sessions, agent, test log. Why did it fail? It failed because it was expecting 3 top URLs, but it got 0 top URLs. So, if we really want, we can dig into this and see exactly what's wrong. In general, if it's failing all the time, then you want to be really careful and check why it's failing, because maybe the test is unfair. Okay, great. And now we've actually got everything passing. And this is actually a really good outcome. So GPT-5 ran 3 times and it passed twice. So actually that's pretty good. It means that both models are kind of struggling a little bit, but it's definitely a fair test. So these are actually really good outcomes. We want something that looks like this. One thing to note is that we're using the Terminus 2 agent, which is not the strongest agent, but it's sort of a fair agent. So all the different model providers, Anthropic, OpenAI, Grok, it sort of treats them pretty fairly. And if you want to think about it, like Claude Code would be an agent, and then Claude, the actual, LLM, that's the LLM. So in this case, Terminus 2 is the agent, and then the LLM is OpenRouter OSS GPT 120B. So we're actually going pretty well. Let's keep going down the README and see if there are any more checks. That's actually it, right? We're getting this, nice pass rates. And then in terms of our own local testing, the only one other thing we want to do, and I don't know if this is in this file here, but we want to do a terminal bench check. So this is another command here, where you would just, I believe it's tb tasks check. I think you need the OpenAI API key to be set for you to do this. So I'm just going to set that. Okay, so I've added the OpenAI API key, and then now we've got the correct syntax. So you put the ID at the end. There is no task ID. And what this will do is it gets a large language model, and that large language model will look at your task and try to determine if it's fair. So it'll look at your solution, and it'll look at your task, and it'll look at your tests. And the big question it asks is, number one, could someone actually make these tests pass just based on your description? So for instance, if you ignored this, right, if you took that out, then, or, if you even, here we go, if you took this bit out, which sort of doesn't say what format to keep things in, and then you ran these tests, which do expect a particular format, then that test is no longer fair because no one could intuit which format you wanted. So you have to be really specific about things. Almost all the time, when you have a task that models fail at, like often, like they always fail, or they fail almost all the time, it's because there's something unfair about the task description. So you have to be really careful with that. Okay, and so this is why we use TB check. So this is the output of TB check, and it tests for things like all the things that are being tested, are they actually in the task? And similarly, do we actually cover everything in the task in our tests? So like maybe we ask for something, but the tests don't check it. The reason that that's important is because this is going to be used to train agents in like an RL setting. So if something is asked and there's no test for it, then an agent might learn that it can ignore that requirement, and it shouldn't learn that. The agent has to learn that, it always has to fulfill all the requirements. So, it's sort of like everything in the test has to be described well, and then everything that's described also has to be in the test. So it sort of has to go both ways. Anti-cheating measures. This is another one. So sometimes you'll come up with this really complex scenario, where there's like 4 servers communicating with each other and like saving the Postgres and like reading from Postgres, all this stuff. And then you'll run a test, which is like, okay, the input has to be this and the output has to be this. And then a very smart agent will eventually learn just to mock that. So the only way to run tests in those cases is that you have to like check that each stage of the pipeline work. Like you have to have a test, and the test which tests the input and the output. And then it also tests the intermediate states and make sure all those intermediate states match and are correct. So, okay, there are a few other tests. Some things like pin dependencies don't matter, typos don't matter. But like these three are really important. Behavior and task description, behavior and tests, and anti-cheating measures. Okay, things like informative test doc strings, yeah, that doesn't matter so much. But okay, so that's great. You know, the TB check worked, and then so did our hardness check. That all passed. That's really good. We're actually ready to submit. We're ready to make a submission. This is gonna be great. We're gonna get our money. We're gonna get paid, and we're gonna help teach AGI. Right? Our little task is going to be part of the huge, immense, world-spanning brain that's going to take over the world sometimes. That's pretty cool. Okay, so we've done our thing. We're just going to push to GitHub. Git status. Yeah, so we'll just commit. I have this nice GCN, which just commits everything. Push. And okay, branches. We have this thing, it's first task 2. It should say that it was just committed right now. Nice, pull requests. And then we're just going to merge this into the, not main, but review. We're going to merge it into review. When we do this, a GitHub bot is going to do some automated tests. And if we fail, then a reviewer will just come and instantly reject us if we fail the automated tests. When you do submit your PR, a really helpful thing to do is just copy all of this, the check output, and put it in your PR. Now, if everything passed and you're confident that it'll pass, and you don't even want to bother anyone with it, just say like, the checks all pass. It's an excellent submission. But often you'll see that some of the checks, they fail, and maybe they fail for like a sort of like edge case reason, or maybe when you run TB check, it fails half the time and it succeeds half the time. So in cases like that, you'll want to actually put the checks in. You want to actually submit the checks and then explain why you think your test is still good, even though it doesn't pass the checks. But you'll also want to say what the pass rates were. So OSS equals 40% for 3 out of 5. GPT-5 equals 1 out of 3. Okay, great. So that'll just, that's just your local results, and that can help us interpret what results the automated checks get. So great pull request. Okay, marvelous. So now we've done a PR into the review branch. Now we just need to copy this PR, and then we'll put it in Discord. So you'll have a personal channel with just you and the Passwave team. So you can put this link in there, or you can @ one of the reviewers, or you can just say @review in the general channel or something like that. Just let us know that, okay, you've made a submission. And okay, we can see that the GitHub bot, now the bot may not fully be working at the moment, but eventually it'll run all these automated checks. In fact, I'll make another video about the GitHub bot. That's a whole other story. But yeah, point is we're doing some automated stuff on the back end whenever someone makes one of these. And what'll happen is a reviewer will just come along and they'll just give you some comments. And maybe they'll say, oh, that's excellent, that's brilliant, we love it. Great task. We love you, excellent. And then in that case, that task is done, and we'll give you your hard-earned cash, and then you can work on the next task. Quite often there'll be some comments like, oh, this doesn't seem fair, or this, we could maybe make this a bit harder, or like, GPT needs to pass more than that, or something like that. But in this case, this is actually a really good task. It's a really good task. So in this case, the reviewer will be like, yeah, nice, good, sick. Okay. And that is how you submit one of these tasks. That's how you do it. A lot of people have a lot of difficulty submitting the first task, so we wanted to make this video just to pull you through the whole process, make it a lot easier. Some final thoughts. We love long tasks that take many commands to complete. So not something that can be completed with a big chunk of code and executing a big chunk of code. Something that requires 8 or 9 bash commands, that's brilliant. Or maybe like 6 bash commands and executing some code. Something like that. We also love machine learning stuff. So anything to do with machine learning. Development, testing, exploratory data analysis, all the way through to model deployment or model quantization or just running like benchmarking, all machine learning stuff we love. So we're more likely to accept tasks like that. But yeah, fantastic. Hopefully this was interesting. I have a lot of fun writing these tasks. It's kind of, it's difficult, but it's fun. And there are sort of not that many things left in programming that are still difficult and fun. Most things can sort of be done very well by AI agents, but making tasks like this I find it pretty engaging. And the other really nice thing is it actually teaches you a lot about these capabilities these agents have. What I learned by making these tasks is that agents are really goddamn good. And usually when an agent screws up, it's probably not because it's the agent doing something wrong. It's probably because your mental model of what's going on, the system that you're trying to solve, there's something wrong with your mental model, or you're not being specific enough. So I found that really interesting from making these tasks. Okay, that's it. Good luck.